Mike? For Tom Clark, I guess I am loud. First of all, good job on your presentation. And my question is, followed mostly everything, but had a hard time grasping the decarbonization and the sludge recirculation. Please explain that to me, us again, and dumb it down. At least for me.
I'm probably not the most perfect person because remember, I'm a biologist that kind of is like dangerous enough and everything else to where, but like, you can, there's a lot of, these discharges pop up with a lot of metal acidity. They're dissolved metals, right? And they come up with a lot of carbonic acid as well. So if you can decarbonate these waters, and Brad Schultz is probably licking his lips over here. He could probably answer this way better than I can. But like you can move pH and say, Brad. Hey, Brad. Is Brad here?
No, he stepped out.
Chuck, you can probably answer this better than me. You want to answer it? I know where I'm getting outside the rails. Oh, hey, thanks.
Yeah.
Shaking your Coca-Cola bottle, and so you have an excess of CO2 in it, and we're able to outgas that carbon dioxide to the atmosphere. That same dissolved CO2 will consume base. So if you added lime to that water, you'd end up using more lime just to neutralize that carbonic acid, which instead could have been decarbonated by aeration. So that would be an initial step in an active treatment plant. Now, the benefit of that is it increases the pH. And with the increased pH, the dissolved iron, it oxidizes faster and faster as a function of pH. So the same amount of oxygen, that's not the factor. So for an increase of pH of 1 unit, so go from pH 6 to 7, you increase the iron oxidation rate by a factor of 100. So where you may have needed a big pond, now you can accomplish it in a very small space, small footprint.
And that sludge that you recirculate, you'll have some unreactant in it, and that sludge is of high pH anyway, so when you start recirculating that, and iron is its own catalyst as well, there have been plants now where you can get away from essentially using lime, and you're decarbonating and you're recirculating this high pH sludge, and it saves a lot of money because hydrated lime right now is pretty expensive, and the more plants we built, there's going to be more demand, and I imagine that price is probably going to get higher. So anytime you can get away from using lime is a good thing.
Yeah, so that sludge is basically iron oxide, and that also accelerates the iron removal because the dissolved iron will actually adhere to it. And once it sticks to it, it oxidizes. And so that actually becomes another mechanism to more rapidly remove the iron, and it makes the sludge denser so it settles more readily. That's another expense in treatment. You have to remove the sludge that's suspended to the bottom of the pond or the clarifier. So yeah, the concept is it's workable. It's demonstrated.
Thanks, Chuck.
And just speaking for SCRA, I think we'd be very much interested in what each of you would say to the question. So just think about it for now. Is what should, let's say us as SCRA, what should we be arguing for? You specify a number of needs, things that, what would you, if you could write your own funding, what would you like to see done? And you authorize yourself to do it. I'd just be, so we'll get to that question, but just think about that if you would. What would you do? What should we be arguing for? Let's see. Jordy?
Are we supposed to introduce ourselves? Well, I will. So I'm Jordy Comas. I work for the Department of Environmental Protection in the Office of Environmental Justice. Especially Mike and Bobby. What are some barriers or hindrances to either integrating the mapping data you have to other mapping data and or getting that in front of decision makers? And is there something state government could do to help with either one of those? Does that make sense?
Well, I think from what we've seen is that the other mapping data that might be available, what we're looking for is flow and chemistry. And there's not a lot of flow and chemistry that are current and that are giving you a hydrologic year, 1 year. What we've always said and others have said is, if I have a drought year and I'm monitoring for that year, am I capturing what I need to capture? And if I decide to build a plant, am I going to scale it appropriately? No. If it's a wet year, you know, and so what Tom was talking about, the highs and lows, you get that over a hydrologic year, and that's why in the AMD-AML program, they want you to have that data, because it's not been collected in that term that you need to even make a good decision. So looking back at data from Scarlift and looking back at data that might have only had one monitoring data point in the 70s, let's not do that. And monitoring point, even USGS had a few points in the 90s, but you need more than just a few points, and you don't want to be looking at that data that far back other than to see maybe it was a historic high or low, but you got to look at the changes that have happened over the last 30-some years. And in most of the watersheds, including Shamokin Creek, that those pressure transducers, those opening of the boreholes and daylighting them to get at the water elevations and to get that throughout the year, that's something that you're not the only group that needs to have that done. Almost every group that we work with across the region in Pennsylvania, it's come out in our survey from last year at the statewide conference on abandoned mine reclamation that Power funded with PEC. It said that some of those needs are the monitoring needs so that we can make sound science decisions based on having the data that's, you know, out there. Now, there might be like data that's, you know, air data from NOAA, if that's even, if there's still data available from them, but you know, when looking at that type of local weather data, that would be very helpful. The precipitation data is going to be helpful. That can be done right here in the watershed with a rain gauge. That's not a big deal. But to get that continuous data, that's something we need to do. Other state data or other federal data, I mean, I'm not sure what else would be out there, but we're looking for data that's specific to us to be able to determine the load-ins. And for all the data that's been collected, if it was just water quality, yeah, it helps us a little bit on water quality, but it doesn't tell us about load-in. It doesn't tell us about how we multiply the flow by the chemistry to get the load-in per year, you know, and to work that into the factor for scale of treatment. And like Tom had said, most of these discharges that we're talking about, it's passive treatment might have been from 20 years ago. We've learned our lessons and know that in some cases here we need to go active, and we're having to really take a hard look at that. But to do that, take the advice of what the John Smoyer and the program from the AMD and AML at Bammer has said, is to get your data up front in that development planning phase so that you can make those decisions before you start thinking about design construction.
You know, just to give you a real-world idea or a real-world event that happened, Jordy, that kind of coincides with what Bobby's talking about. We have we're doing a development project for a plant down on Shade Creek in Somerset County on discharges that have a pretty decent back catalog of data, historical data set. There's a discharge there, Loyalhanna 6. The high flow there over that historical record was a tick over 5,000 gallons a minute. I don't know if you've seen, but like Somerset County got over 10 inches of rain in the last month in May. We had a transducer set up there. That discharge got up to 13,000 gallons a minute. It was never captured in the historical record. So like when you're building a plant, the operator's going to want to know that if I get a 4 or 5 inch rainfall event, it's going to be 13,000 gallons a minute, and how do I manage that? If we didn't have those transducers in, we would have never known that. And like now our clarifier size is a little bigger. Everything got a little bigger because it moves your 95% confidence interval and that kind of stuff. And Bobby's right. It's so important to have that high, and that within that year, like what you're saying, you got to hope that you have a high flow period. You got to hope to have a really low flow period, because you got to understand all that. If you have kind of like a static flow year, you could, right, you're not capturing what you may need to know.
And in some of these discharges, as large as they are, you're not just going to get out there with a flow meter and do a cross-section to get your flows like these guys have tried to do on the Old Forge borehole one year, probably almost cost them their lives, going across the river to get a flow, you know, doing upstream and downstream. So in some cases, with as large as some of these discharges are, the pressure transducers and the ways that we can do radiance curves to get us the gauges, to give us the levels we need, it's safer and going to be more efficient to do that.
Anyone else for now? There we go, Chuck.
This is sort of a question that each of you might have an opinion on, but the high flow issue it could be a limiting factor, not just for design, but for aquatic life, right? So in addition to just monitoring what's going on for the purpose of design, is there a way to understand how, what would happen in the event that you either bypass water or stop treating it for a period, or half the water doesn't get treated? What would happen to the stream? How do you make a judgment on that? I mean, and is that the criterion that you could use to decide what's acceptable to not treat during a high flow event?
No, I mean, you have a big slug that might come down and, erase all the work that you've just done to treat that stream. And, the biological community that's there, the fish, the macros, could get wiped out, and it takes a long time to recover. So yeah, that's why it's important to try to do what you can do for those high flows, whether it's increasing the size of the treatment system, or, if there's ways that you can store that, with the pump storage, and have it be safe and not a catastrophic event that might do more harm in the way of subsidence than it would to mitigate like a slug that would come down like that. Yeah, so.
I think one of the things we encourage and that we do is we go after, with the watershed groups and conservation districts, Pennsylvania Trout Unlimited's Cold Water Heritage Planning Funds, funded by Foundation for PA Watersheds and Fish and Boat and DCNR, and doing that preliminary assessment of the watersheds that gives us a baseline of both the ecology from the macro standpoint and from a fishery standpoint is another aspect for economic development and recreational component for the streams. This potentially could happen here in Shamokin Creek. We know just downstream in the Cameron, what's the first tributary to the right? Trout Run. Is there fish in it? Yeah, it's called Trout Run. So, and there's a barrier down there that we're aware of that's preventing fish from migrating, like maybe I think it might be a concrete block of a sewer mine or sewer.
Flume.
Yeah, or something's down there that's preventing water from migrating up further. But if we were to look at it from an assessment standpoint and to make recommendations for implementation, we could eliminate some of those other barriers when it comes to downstream aquatic communities being looked at on a more holistic scale, and then go after some other monies for implementation that when you apply for these grants, they're looking for that. And PA2U has been very good about doing those kinds of projects and plans to let us get funding to do the assessment work that usually isn't done, but it can be done in complement to a development plan with Bamber. But these are straight $10,000 projects that if you put in for the assessment, you probably can get some boots on the ground real quick, maybe do some of that work up front that will help justify some of the things and how you're going to eventually treat any overflows or high flow situations.
Too, Chuck, you bring up a good point, particularly these large mine pools. Sometimes, as you know, the high flow can be delayed through the system, right? So your stream, if your discharge is high flow and your stream's high flow and you're bypassing, that's not a real big deal because the stream is at flood stage or higher. However, that stream may come down quicker than what your discharges come down. So that's why it's always you can bypass, but what's the level of bypass that's acceptable, particularly biologically? But how can we, to me, on these big discharge situations, these big mine pools, the better, to me, it's how do we just eliminate the need to bypass? Yeah, you probably have to some sort of emergency, right? But can we do that underground and just get away from that because of that delay that could happen between your high flows? Stream high flow here, but 2 days later is when you're getting your discharge high flows. And that's something to think about when you're designing these plants.
I'm retired. Thankfully. No, I just don't have enough experience with this issue.
The delay in the high flows.
Yeah.
Well,
That's
and I think the one you're talking about with the flooding was an issue for that watershed. And so there was some concept that when you keep the stream from losing to the mine pool, you might increase the flooding. So these kind of decisions are often trade-offs. And it's kind of where I know just a number of people in the audience are not really focused on the technical side of this, but the community engagement. And, you know, the more you can do to educate the community with the better mine pool map, for example, and things like that, to get the community behind which trade-off the experts are picking, you know, and why. But there's always trade-offs, you know, often money versus everything else. But even in this case, there might be biological trade-offs versus, you know, driving on the road or something. So it's a challenge, but no, I don't have the answer.
That's a good point.
In addition to the year-long data, 2-year-long data, the transducer, is that what you call them? I'm just curious, like, are you also looking at climate change, like modeling to kind of look at like not only what are we looking at the future, for the future of different potential rain patterns and things like that to plan for that? I mean, I know no one can predict like a, you know, 10-inch spot storm or whatever, but I mean, is that also taken into consideration when you're designing these?
I mean, I'm not sure of climate change models that we could use, but we do talk about climate change in the sense that from a localized rainfall event, when you have water that's fallen in a particular area, there's a certain number of inches that might come down during a rain event like Tom was talking about in Somerset and that area out west, or we may have a big hurricane storm that comes through. You're looking at what can that drainage handle, and it's usually a flash flood situation, or it's going into a stripping pit, or that's holding the water back, or the water's going down into the mine pool. And if you're talking about doing restoration work, you got to take into consideration now, not only where's all that extra water going, it didn't account for the additional flow, you know, that now after you reclaimed a pit and you restored the water to the surface through abatement, I've got to come through 3 or 4 culverts or railroad underpasses or bridges and pipes that are undersized to begin with in these communities. And so talk about infrastructure and replacement. I can't imagine what it's going to cost to replace the bridges just to keep Nanaco Creek on the surface, but that's a part of the overall plan. And what we are saying is that water going into those pits then that are now trying to be restored to the surface, we look at that from a standpoint of climate, you know, in terms of the rainfall events, because that does increase flooding downstreams if you don't deal with it properly. And the pools and the lag time between water going in to the mine pools and coming out, that's going to be different in a lot of different mine pools once we understand sort of storage capacity and how much water can go in and what can come out. But that's what forces a lot of the discharges to have blowouts, and that's why we have downstream flooding issues sometimes, because there's an increase in the water coming from the mines as well that you have to take into consideration in addition to the flashiness of the rainfall events in our communities.
You know, it's a valid point I think you bring up, you know, like just for that instance down Somerset County, hopefully we caught what we could expect here maybe in 10 or 20 years as climate change maybe changes our precipitation levels here. But like if climate scientists are saying that, you know, Western Pennsylvania is going to get 10% more rain, maybe that is the contingency that you put into your design to where you're like, all right, we think we have a better idea. We think we have a good idea of what the high flow is, but based upon these modelings from climate scientists that are coming out, do we push it a little higher? And like, for instance, I'll just kind of another real world example at Morris Run, we have an historical record there that shows these discharges are, I think are like 12 point something MGD on the high. We've designed that plant to be able to treat 15 million gallons because one, we're not sure if that was the absolute high, and it gives you that buffer that like what you're saying. So, and then when you're getting to the point where you're building 120-foot clarifiers, the economy of scale to go from 12 to 15 MGD isn't very much, and it's not going to cost very much to go from 120 or 125 to 130. It just isn't. So but it's a good point, I think, that should be considered.
Okay, question back here.
Hi, I know you're retired, Dan, but I'm going to ask you anyway. You can send me back to the report if you'd like. I'm thinking about linking up some of the material from this morning with this session. And one thing I'm thinking about is your velocities calculated in mine pools for drainage in the Shamokin Creek. And I'm wondering if they reflect that open channel pipe full flow that some of the discharges are going to have, or if you're assuming laminar flow throughout as a typical mod flow model would.
The latter, actually. So in that particular study, we use steady state models. So, so basically the hydraulic conductivity or the permeability, if you want, is controls everything in combination with where your withdrawals are and then where the land surface is. So there was no, and we don't, the results of that are not velocity of contaminants, for example. We don't do that because you would need an effective porosity of some sort, which is basically we need to do tracer tests, I guess, to get something like that. But we looked at other studies with transient models where you can see there are even more parameters, of course, because now we have time to deal with, and then that's a whole another issue with the characterization. But for me, start with as simple as we can to get meaningful answers that address the questions that the decision makers have about what are we going to do. In the case of that study, one was, should we pump Gilberton more? How would that affect the situation? And we just looked at that from a steady state point of view, nothing to do with flooding or these transient events.
I think the reason that this question interests me is I'm thinking about putting geothermal down into a mine pool or something like that. And if we don't have accurate flow velocities, the engineering is going to be different. Or if we do have accurate, rather, let me rephrase that, if we have accurate flow conditions, we may have a better understanding of how that system would respond, both physically and chemically.
Absolutely, and I could for sure make a model for that, and with no data, then I can do whatever I like, okay? So it'd be an easy project. To me, the way the goal shouldn't be a model, the goal should be modeling to get all the information you can out of your data. So the first thing I would do as a modeler is go back and run field tests of what you're trying to learn about. Like a pilot system where you have this, and I'm going to call it groundwater heat pump system. Build one of those somewhere and monitor that in a mine pool to see what the issues are. Is it that the actual flow rate through those, how you build your system, does the flow rate matter a lot? Or is it just that in a big mine pool, you're essentially in a pond underneath the ground, and I would think the heat moves a lot better in a pond than it does in solid rock. So that, to me, is the first level benefit of using the mine pools for that heat pump exchange.
I got a question. A gravity-fed active treatment site is going to be a lot cheaper to run than a pumped, we'll pump a mined water to a plant. And we know these new plants are going to have redundancy where there's two clarifiers, so you're working on one clarifier, you could have the other one shut off. Isn't it cheaper not to pump the mine pool, keep it as a gravity-fed system, and then only operate a second clarifier when the times of high flow come?
Say that again.
I was like, I follow you, Steve. It just, thinking about a Shamokin Creek situation is, so I'll ask you a question back. If you are capturing from the outfall, how are you going to deal with these extreme flows then, if that's the way you're going to capture them and gravity feed them into a plant? No, I'm talking even like clarifiers and reaction tanks and stuff, and it's just, that's where I think the complexity of like Shamokin Creek and Mahanoy Creek, to where, are you going to have those situations where you could capture from an outfall and gravity feed it over to a plant? I think so, and like, particularly on those smaller flows like Corbin and Maysville, you know, putting Big Mountain in, I think that's possible. But that in my mind, and people can disagree with me, the overarching problem within that watershed in Mahanoy are those extreme high flows that, to me, might have the ability to be managed properly with a good pumping plan. I just don't know how you do it if you're just capturing right from source and you have a Somerset type event that happens on your discharge. And then the bypass, and then we go back to the question about, I think Chuck's question about the impact that a bypass can make to the biology, because that's ultimately what you want to bring back on Shamokin Creek. You want to bring back the bugs, you want to bring back the fish, and then you have that delay period where your stream's fallen, but your discharge flow could be going up. I just don't know if that's feasible in a Shamokin sense, I guess is the way I would answer that. How can you do it in the pool? I don't know. I don't think any of us do. We don't have enough data to confirm how you would do it. So to me, the first step is to put transducers on all your outfalls, put transducers on everything that goes down into the mine pool, have that precipitation. You know, we have a digital in Shea Creek. We have a digital rain gauge there that reads out to us. Those are the things that once we have that data, that's, you know, where can we pull from an outfall? Where are we going to have to try to pump control? That's kind of like where I am with that.
Tom, if I follow up on Steve's question, initially I thought we could get off sort of easy by targeting the small number of locations you mentioned and measure the flow with a few transducers, but now I'm thinking, oh no, you're saying to capture the peaks, which is really what you to manage. Now we're talking about a higher cost, and you want it continuously. You don't want a snapshot every now and then, right?
Oh, so we have these transducers set up, like in Shea Creek. We drilled boreholes. We have them down in Tara mine pools. We have them at all the discharges. In Shamokin sense, we should, you know, because you have these stream loss sections, you should probably have piezometers around these stream loss sections as well. And every one of those piezometers should be picking up the same data at the same hour, whether you set it up for every 15 minutes, every hour. And then all of those transducers are setting up real-time data collection, capturing precipitation events. So like, that's why like, I'm thinking like 40, 50 transducers input into a watershed at one time, all paired, all, what do they call that, synchronized. And then you hopefully, you almost, I hate to say this, but you're hoping for a high flow event. You're hoping for a real dry August so that you can get those ranges. Then that's what you need to be like, well, where do we put it? How do we treat it? What, you know, can we control the flow? Does that kind of answer your question?
Yeah. So we should have a fundraiser, a bake sale or something, it sounds like.
Nice thing about those transducers, anything technology, it seems like they're decreasing in cost over time. So just wait a little while, you know, and then it'll be less cost. And then, like, that's what it seems like is happening.
$400, $500
Yeah, they're like $400 or $500, you know.
There's also a labor cost to managing that network, and that's not trivial. It requires a commitment. And you want to comment on that?
Oh, yeah, so Chuck said there's a cost, a maintenance cost that is not trivial, so that should be included, but, yeah.
Oh, yeah, so what he's saying is that, you know, we have to go out and collect the data from these transducers, and if you're talking about 40 of them, that would take a while. And basically what you're doing is, you know, the transducers that we work with are Solent. They're down on a, you know, wire rope that's coated. You pull them up and you connect them to a, basically a little device that connects them through Bluetooth to your phone, and you can download the data. Do you want me to download that monthly, quarterly?
That's the thing,
Yeah,
I don't
so
think it
that's-
has to be that rate, Mike.
Yeah.
Like, I always go out
What if it falls off?
well, I always go out, like, my
How
thing
much
is,
data do you want to lose?
I always go out like the first month to make sure they're working, right? And if they are working, you know, I send them down with a wing and a prayer, you know, that they're going to work through the next 11 months. But that's how the way I've handled my transducers, and I've had pretty good luck with them over the years, you know, in terms of like.
So, yeah, they're expensive. Basically, you have it down the borehole, and then whatever length of cable, communication cable, comes up to the top of it. And yes, there are ones that have like cellular chips that would communicate the data.
Bluetooth ones, they have Bluetooth ones, which are nice.
Or you can drive, again, but you would have to drive up to it and be
But
within
it's not
10
like
feet
you
of
got-
it.
It's not like you're bringing up a cable
True.
from a borehole, though, you know?
The other part of that is managing data. And when you're out there manually downloading, you're also manually checking.
Yeah.
Is that reading that I'm getting off the device
Does it make sense? Yeah.
take down measurement or my stat rating or what have you? So if there's a quality concern that, it's again, it's these trade-offs concepts, but yeah, there's more to it than just putting something.
And depending on, you know, the chemistry that's going on down there, you have to bring that up and clean it off every once in a while. I have like a little scrubby brush that I go and take like the iron oxide off of it. And, you know, if you too much iron oxide build up, it's not going to be, you know, reading the depth properly anymore. So
Maybe one last question? Mike?
A hypothetical mapping question. First of all, I am a map junkie. But anyway, a certain person may have an old historic mine map, let's say with a date 1936, looks like a blueprint, might have a name on it like Locust Gap, might be about 14
yes,
feet wide.
yes, yes, we want it. Yeah.
Send it our way.
So what would, to borrow, to,
Sure. Yeah.
right,
I would
and
just.
then what would be the process? What do you do with it then?
So yeah, I would borrow it. We have a map scanner,
52-inch.
52-inch map roll scanner that we would put it through to get a digital image of it. And yeah, then from there, we would just send it through the process. But yeah, I mean, I would just need it physically for a couple days, you know. Yep.
And just so you understand, like the work that we're doing under the current mind mapping program is only to do the progression that the mind mapping program wants us to do with the existing collections that we have that were a part of the grant. So we have, you know, the Cage, we call it the Cage collection. We have like 5,000 maps from Girard Estates that were part of that. We had a prioritization on doing all the deep mine safety maps in Pottsville, all the maps that were in Bureau of Abandoned Mine Reclamation on the first floor in a flood zone. All that stuff was the priority. So we have to do that work first, get that information in, scanned, cataloged, and all the steps that Mike talked about before we can continue to work on the sort of georeferencing and digitizing. And anything outside of that that is happening in a particular project that we may want to be involved with a number of firms or a number of watershed groups or districts, that's a separate project. That's another, you know, we would do that same process, but it would be done under a different project. It's not funded under that particular project with the
Not
grant.
necessarily. If it's Locust Gap, that's a gap for us. It's actually where we don't have a lot of maps. So that would be definitely helpful, and I would talk to our project manager and say, hey, can we add this one in?
Or we can ask
And
him
he
to
would
add
probably
stuff to
say
the
yes
collection.
immediately, yeah.
Yeah.
Was there one more person to ask the last question? Here we are. Okay, Jim.
So at West Virginia, we received a lot of old maps on linen backgrounds that are, or backings that are about 8 feet wide.
Yeah, those are
And then we're, you know, we had one that would almost fill half this room. You can't scan that. You can't run it through a scanner. However, OSM up in Pittsburgh
Yes.
has a department there where they can take some massive, huge maps, like 10, 12 feet long maps. So if you do have some that need to be scanned, go to OSM, and they will accommodate you.
Yeah, they have what they call the Eagle Eye scanner. It's basically a camera in the ceiling, and they, you know, lay out the map on a table, and they can take a picture of it. Sometimes it has to be taken in a few sections, but yeah.
The only maps we can't really do are like canvas backs, because the canvas backs,
They're so brittle.
you open them up and they're going to crack like an egg, like an eggshell. They're really difficult to work with.
Those are some of your really old maps from like the late 1800s, early 1900s. where the paper that they were creating was just so brittle, and you have to open it up in like a humidified environment over like a day. Yeah, and then to try to scan that. To do that. Yep. It does.
Yeah, the best we could do is tape it with acid-free tape, and that's the extent of the restoration process we can go through.
We're not restoration specialists with the maps, no.
Okay, well, thank you, gentlemen.